Okay, so the sort of big topics for this webinar are the InfluxDB CLI and configuration options. And it's going to be me, Michael Desaw, and Gunnar Asen sort of going through this with you. So hopefully by the end of this by this section or this sort of presentation, participants will be able to understand the InfluxDB CLI, command line options, work with InfluxDB using the InfluxDB CLI, and understand the InfluxDB configuration options, and write data into InfluxDB using the InfluxDB CLI. So just sort of a quick sort of recap, just so everybody's kind of on the same page. I'm going to start off with doing sort of a quick overview of what is time series data and what is the InfluxDB data model, just so when we're going through things, stuff makes sense. So what is time series data? So time series data is a sequence of data points typically consisting of successive measurements made from a same source over a time interval. What this essentially means is if you have some data, you plot it on a graph, one of the axes you have would always be time. So this is a great example here of some time series data. We're tracking #RoyalBaby usage over time. Our x-axis is time, so we know this is time series data. Here we have this sort of like web graph, or this graph of sort of relationships between these objects. And this is not time series data because we don't care about how this data changes over time. We care about the current state of this data and the relationships of the various sort of things in the graph. So this is not time series data. We've got another example here of something that's not time series data. We can see that we have these sort of clusters of like sort of categories of things where you could be, a nerd, a superstar, iconoclast, diva, jock, based off of sort of your grades and your athletics. And there's no time in this graph, so we know this is not time series data. Here we have some sort of typical DevOpsy use case where we're on the x-axis, we have time, and we're measuring things like the short-term load, the amount of disk used, the write operations up to disk, as well as the resident set size of a process. So this is a great example of some time series data. Within time series, there's sort of two big kind of classifications. There's regular and irregular time series. The top graph that we have here is regular time series, and the reason why it is regular is the points come in at a fixed interval. So every 10 seconds, every 15 seconds, or every n seconds, a measurement comes in. And that is regular time series. On the bottom here, we have a graph of what is called irregular time series, where it's kind of like event data where the data is coming in sort of sporadically. You may get 1 point and then sort of 3 points really close to one another. This kind of data is irregular time series. So there's a lot of different TSDBs, or time series databases, and why should you choose InfluxDB? My reasons would be that it's really easy to get started with. There's familiar query syntax, no external dependencies. We allow for both regular and irregular time series. Horizontally scalable, and we're a member of a cohesive time series platform. And sort of echoing a little bit what Jimmy was talking about, we have this tick stack, the Telegraph, InfluxDB, chronograph, and capacitor. And sort of we really wanted to capture all parts of time series. So if you don't have a solution for collecting your data, we have one. If you don't have a solution for graphing your data, we have one. And if you don't have a solution for processing your data, we have one. We wanted everything to sort of be together and work well with InfluxDB. The sort of dream here is that you can go from 0 to graphing data and monitoring data and making sort of decisions on time series data as soon as possible. And that's the main sort of reason why we have this platform. And it's a reason why I would choose InfluxDB over some of the other TSDBs. So, quick overview of the InfluxDB data model. Given this sort of typical time series graph here, we got some components. We've got the label up at the top. We call this label the measurement in InfluxDB. In this case, it's stock price. We have the legend, which is sort of metadata. We call these tags. We can see that we have 3 different tickers and 2 different markets. Ticker corresponds to the shape, ticker corresponds to the color, and market corresponds to the shape. So we have circles and squares. The circles are market or NASDAQ, and the squares are New York Stock Exchange. In InfluxDB, tags are index values, and we use sort of this to look things up in the database efficiently. The collection of all of the tags in InfluxDB is called the tag set. So we have things like ticker equals A, comma market equals NASDAQ. So that's the green, the blue circle. That would be the ticker A, market NASDAQ. The green square would be ticker AA, market NASDAQ equals New York Stock Exchange. So the collection of all the tags is called the tag set. The next sort of thing that we have here is the y-axis values. In InfluxDB, we call these y-axis values fields. And fields can be sort of, ints, floats, bools, and strings, all of the 64-bit variety. In this case, we have a single field or a single y-axis value called price that stores the price of the stock. And sort of on a similar note with the collection of all the tags is called the tag set. The collection of all the fields is called the field set. And in this example, there's only one, but there could very well be many. So it's entirely possible that you could have a bunch of them. All right. So the sort of final little piece here that we have is that y-axis value called the timestamp or time, it stores the number of nanoseconds since January 1st to midnight 1970, which is sort of the typical Unix epoch. So the next sort of step is, how do we think about points in the database? How do we represent points in the database? What's our sort of model for thinking about data in there? And we use sort of this thing called this textual representation called the line protocol, which goes as follows. It goes measurement, comma, tag set, space, field set, space, timestamp. So, an example from the sort of graph that we were looking at before would be stock price, comma, ticker equals A, comma, market equals NASDAQ, price equals 177.03, and then some massive timestamp. So if we look at sort of the components, stock prices are measurement, our tag set is ticker equals A, comma, market equals NASDAQ, and our field set is price equals 177. And then our timestamp is the timestamp. So the next kind of thing that's a little bit tricky in InfluxDB is, what is a series? So a series is the measurement plus the tag set. So it's all points that have a common measurement and tag set, which refers to the entire series. A single point in a series is represented by the measurement plus the tag set plus the timestamp. So you can kind of think of the timestamp as the ID for a point in a series. That's just sort of it's a little bit tricky. It takes a little bit of time to wrap your head around it, but we'll continue on because we're mostly just doing this to do some background. On that note, we're going to head into doing some CLI tips and tricks. First thing I'd like to sort of open with is, why should you use the CLI? So why would I not just use the web interface or use curl or any of the other things that I sort of have available to me? And the sort of answer is, it's always there. It comes with every InfluxDB package. It's way better than interacting with the web admin UI, and it provides a number of convenient utilities for interacting with the database. Writing curl statements is not fun. So the next sort of thing, I'm going to actually have you guys download some data. So we'll take some time to have people try to download some stuff. I posted the link to the data set in the chat off to the side. So if everybody could just sort of take some time and curl down that data set, and then we'll continue on. So take about 2 minutes for people to sort of get their bearings on this, and then we'll carry on.
So Michael, in the meantime, there is a question from Francisco in the Q&A if you've got a sec.
Yep, I'm answering right now.
Gunnar is in the process of answering that right now. So if you've already managed to download the dataset, you're going to want to open up a separate terminal or terminal window and start the InfluxD process, just so we have InfluxDB running. And this is just going to be so we can import some of the data and interact with the database. So if you've already downloaded the dataset, take some time and launch up the InfluxDB process. And I really would encourage you all to sort of try to follow along with this if you can. Typing these things out for yourself definitely helps a lot. All right. Sort of on that note, we'll sort of keep going forward. I think Gunnar is answering some questions in the Q&A. So let's talk about sort of what we did here a little bit. So first thing we did, right, is we curled down this mock data set that we have, which is the NOAA water data set. So it's a bunch of water data from, I believe, Southern California. And if we sort of peek into the top of this file, we can see this sort of a little bit of the structure here, where we have this hashtag DDL, create database if not exists, NOAA database. So this is creating a this creates a database in InfluxDB called NOAA water database. And sort of the next thing that we see here is a bunch of data in line protocol. So if you opened up this file with not using head, there's thousands and thousands of lines, so you may not want to do that. But we can see that we've got this sort of H2O feet with some location data and some water level data and some descriptions and some timestamp. So this is sort of just a quick sort of way to, or just a peek of the structure of the data that we're working. We're just putting in a bunch of water data into our database, and then we're going to sort of issue some queries and see how we can play with the format. So now that we've got that sort of data set downloaded, the next sort of thing that we're going to get into is the CLI. And the place I want to start with is the -h flag. So if you haven't already, please take a second and type influx base -h into a terminal, and you should see this massive sort of output here. So take a second to sort of get that, and then we're going to go through and talk about that. So type it up, and cool. So the sort of things that we see here are the various flags that InfluxDB allows. We can see there's a ton of them. Got the version, which is the version influx version of the Influx CLI version, not the InfluxDB version. The -host, so you can use the CLI to connect to a random host or an arbitrary host if you don't want to just run it locally. By default, it will run locally. If your InfluxDB process is running on a separate port, you're going to want to use the port flag. If the you want to connect to a specific database on a server, then you're going to have to issue the database command. If there's a password required, then you will need to give a password. If there's a username, you'll have to give the username. So username and password should typically go together. If you are using SSL, you'll have to use the SSL flag. The unsafe SSL flag, I don't know what it does. So it looks like we're going to skip over that one. The next sort of thing here that we have is the execute command. The execute command is probably one of the more interesting ones out of the things we've listed above. This allows you to execute a command on InfluxDB and then just quit immediately after. So it's a very efficient way to sort of get data out of the database, and it makes there's like the equivalent curl statement that you would have to write to get that data is usually a lot more hairy. So you'll probably want to use the execute command. The next thing we can see is there's sort of we allow for outputting in 3 formats. You can do JSON, CSV, or column. So JSON is the JavaScript object notation that everybody knows and loves. CSV is the comma-separated value that everybody knows and loves. And finally, we have column. And column's kind of like our own sort of way to represent InfluxDB data. So it's probably the most easiest to look at for a human. CSV is probably the easiest to process, and JSON's pretty easy as well. The next thing that we can see here is the precision flag. The precision flag tells us, the format of the timestamp that will be returned to us. So RFC 3339 is a format that is sort of the typical date time that you know. And we can specify hours, minutes, seconds, milliseconds, microseconds, or nanoseconds. We'll see what all of those do in just a second. Consistency is a write consistency. So how much guarantee do you need before a write is accepted by the database? And that only comes around if you're inserting data into the database, which we won't be doing until the end. And pretty will make your JSON pretty. And finally, we have sort of this import flag here, which is a way to import some data. So that mock data set that we just downloaded, we're actually going to use the import flag to import that data into InfluxDB. Right below that, we have a PPS flag, which can you can throttle the data that you're importing into the database. Path is the path to the file that you're going to be importing, and compressed is is this file that you're giving me compressed. So that's a lot of data. I just want to quickly go through all of that. We're going to go into more detail on the ones that I find particularly interesting. So now that we've talked about some of the flags, let's get the sort of basic data into our database. So the command we're going to want to run is influx, so just the typical influx CLI command, space -import, space path equals NOAA data.text, and -precision s. So what we're doing here is we're saying import all of the data that's in NOAA data text and make sure that when you write the data, the precision that you're using is seconds. So if you don't do this, the timestamps that are written in will be in nanoseconds. Nanoseconds are the default. And all of our data will be maybe a couple seconds or a couple minutes past into 1970, January 1st of 1970. So you're going to want to definitely give that precision flag. So when we issue this command, you should see something like processed one command, and processed 7,290 inserts. And failed 0 inserts. So we successfully wrote all of the data into the database. So now that we've got some data in there, we're going to want to pop into the CLI to start poking around. So the first thing we can do is just type influx. Just a bare influx will take us into the influx CLI shell, where we can sort of insert and execute InfluxDB commands or queries. as well as a couple additional things. So the first thing that I would want to do after popping into the database is verify, or into the CLI, is verify that the database that we just sort of imported all of our data to exists. So we can do that by issuing a show databases command. So when we say show databases, we should see two databases, the underscore internal database, which is there for sort of every sort of typical InfluxDB install, unless you don't have it, which I would recommend you should just always have it there, unless it's causing you a bunch of performance problems, which it shouldn't. And the second database we see here is the NOAA water database. So we created our database, which is great. The next sort of thing we're going to want to do is we need to tell the CLI which database we want to use. And the command to do that is use. So we say use and then NOAA database, or the name of any database that you want to use. And what this does is it sets the context for the CLI to be the database that you sort of specified. And since we want to be working with this NOAA database, we're using that database. The next thing that we're going to want to do is issue sort of a basic select statement. So in InfluxDB, the query language is very much like SQL. So if you know SQL, you should this query should be obvious to you. And what we're saying here is select star from H2O quality limit 10. So the sort of essence of this query is the star is give me everything that is under the measurement H2O quality, but only give me 10 of the results. And the reason why we're doing that is because there's thousands and thousands and thousands of these, and we don't want to, spend. I can't fit all of that stuff onto a screen. The things I'd like to sort of call your attention to here is, if we look at the results of this, we see that time is just this massive sort of number over to the side here. And we can see there's sort of like, there's this like line where everything below it is zeros. This kind of time, to me at least, is completely meaningless. I can't tell you when this was. I can't tell you if this was this year, last year, 10 years ago, or maybe, maybe 15 years ago. I have a rough estimate because I work with large timestamps like this all the time, but it's very hard to determine what is going on here. What is the meaning here? And because of that, InfluxDB provides a utility so that you can change the precision on the time. So precision specifies the format of the timestamp. The options that we have are RFC 3339, which is the sort of human readable date time that everybody knows. You can do hours, minutes, seconds, milliseconds, microseconds, or nanoseconds. There's two ways you can specify what precision that you'd like to use with Influx. You can do it when you start the Influx CLI process by issuing influx space dash precision RFC 3339, which says, use the RFC 3339 timestamp format. Or if you're already in the CLI, you can use just issue a precision command. So if I issue precision space RFC 3339, then all the data that I get back from this will be in that format. So just a little bit of an example sort of this. We're going to take the basic select statement, but use precision RFC 3339 instead. And when we do that, we see this nice human readable, understandable date off to the side. So, this data is on the 8th, which is August 18th of 2015. And we can see that, it's like it looks like every 6 seconds or 6 minutes, every 6 hours, every 6 hours data is coming in. The next sort of thing we can do, just to sort of change it up a little bit, is we can see what the precision was. We can change the precision to be hours. So if we say precision H, we issue the same sort of select statement, and we see time is now in hours off to the side. And now this is a little bit confusing because the precision that we've set, sort of given has the exact same time. They all occurred within the same hour. Same number of hours, yeah, which is a little bit odd. And that's it. This must be coming in every 6 minutes. Yeah, it is. So the data comes in every 6 minutes. We only asked for sort of 10 data points. So all of the data that we asked for got lumped into a single sort of timestamp. So this is mostly just an illustrative example of you can set it the precision to be hours. The next sort of thing that you can do is change the format of the results that get returned to you. So this can be done with the format flag. So the format specifies what format the server responds with. So it can be JSON, CSV, or column. You can specify the format in one of two ways, pass in the command line flag, or if you're already into the CLI, issue a format command. So if I say format JSON, it'll format the data as JSON. So let's take that same select statement and run it with format JSON. So issue a format JSON command. And when you do that, you should get sort of no output. And when we issue it, we see this impossible to read sort of JSON in here, which is very easy for a computer to parse, but not so easy for a human. And as I note here, this is kind of awful for a human, that is. So if we want to make that JSON sort of easier to read, InfluxDB provides a utility to do that. So if we issue just a pretty command, so if you're in the CLI, just type pretty, or if you want to pass it in as a command line flag, that's completely fine as well. When we issue a command, we can see this nice sort of pretty looking JSON where each of the keys is on a separate line. The final sort of format that I'd like to sort of talk about is the format CSV. So if we specify issue a format space CSV command, or if we would type that when we were entering the CLI, we would see, issue the typical select statement. And we also have something that's kind of readable here, where the column names are name, time, index, location, and ran tag. And, we have the things line up appropriately. This is probably the easiest one to use if you're doing sort of large scale processing. JSON's got a bunch of extra unnecessary data. The next thing that we're going to sort of get into is that execute flag. So if you could pop out of the CLI, to exit the CLI, you just type the command exit. And we're going to use the execute flag to issue a query without ever entering the CLI shell. So to do that, we say influx space, we specify the database that we'd like to execute the query on. So in this case, we want to use the NOAA water database, and the execute flag should have the contents of the execute flag should be the query that we'd like to execute. So in this case, I'm just issuing that same basic query that we had talked about before. So select star from H2O quality, limit 10. And the output that we get is sort of the what we would have seen had we been in the CLI. And this can be, I can imagine people saying, oh, why would I ever want to use this? It's a lot nicer than issuing the same curl command. So same curl command, you have a bunch of sort of extra stuff that gets a little bit more confusing. And it's a lot easier to reason about the database as this sort of abstract thing rather than thinking about what query parameters do I need to set and whatnot. So the next sort of thing that we didn't talk about a little bit, but we can connect to a remote host and issue queries there. So the same sort of things that I had before. So influx space dash database, the name of the database, dash execute space in the query, and then space dash host, and then some host name. If I do this, it will execute this query on a remote host. So, whoops, I had the wrong photo in here. My apologies for that. But so if we were to issue that query above, and that IP address was a valid IP address, what would happen is the we'd be querying that remote InfluxDB instance instead. So now I'm just going to do a sort of quick overview of some meta queries. So if you're ever in the CLI and you sort of want to know what the shape of the data that you're working with, there's some sort of commands that we allow you to do this with, and I'm not going to go into them in too much detail. That's a sort of separate topic. But there are things that I think that are important that sort of go along with the InfluxDB CLI. And sort of what I do if I'm given an Influx instance and I need to figure out what's sort of the state. Okay, I pop into the CLI and then I'll issue these sort of 4 commands here. I will issue a show databases command, which will show me all the databases that exist on the instance. I'll issue a show measurements command, which will show me all the measurements in a particular database. I will issue a show tag keys to show me all of the possible tag keys for each of the measurements in the database, and I'll do a show field keys. So essentially what this does for me is this tells me what the shape of the data is. It tells me, what measurements there are, what tags there are, what tags have which fields. So I can start to sort of think and reason about data in the database. And I would encourage you, if you ever have no idea what data is in your database, which most people do, and they have absolutely no idea what's in there, to sort of explore in this way and try to get a feel for what's there. If you sort of take this together, it allows you to sort of make these basic select statements that you can sort of build off of to get meaningful data or meaningful information. The next sort of thing that you might want to check out are the various retention policies and continuous queries. So these are 2 meta queries that you can see what your retention policy is. A retention policy is like a logical container for points in InfluxDB. So also a separate sort of talk. We'll be doing sort of more webinars and things like that. And we can see the various continuous queries, which are sort of the way we move data throughout the database. You can downsample or maybe pre-process some information that you query frequently. So in addition to if you know the shape of the data and you know the data expiry, then you should have a really good idea of what this InfluxDB database sort of looks like, and what's going on with the state of the database, and what are the contents of the database in my mind. The next sort of thing you can do is issue, if it is a cluster, you can issue these sort of meta queries about the cluster state. So we have a show servers, which will show you all the servers that belong to a cluster, and we have a show shards, which will show you which nodes in the cluster have which shards. If you have various sort of replication of data throughout the database, it helps you sort of figure out where things are. And sort of the final 2 that we have here are show stats and show diagnostics. So if you ever get a sort of query, or if you ever email into support, or if you ever ask us a question, probably one of the first things we're going to be asking you to do is tell us the statistics and diagnostics, which are some bits of information about the current state of your InfluxDB instance, or your InfluxDB process. We're going to skip over write performance. The other question that you're going to see us ask probably almost immediately is, how many series do you have on your database? So the number of series that you have in your database largely determines how your database performs and how many resources the database or InfluxDB instance will require. So if you ever want to figure that out, we have this sort of nice command here. So you can issue an influx-execute show series, and then space the database name, and then pipe a bunch of seds that will sort of count the various lines that get returned from this. And this will tell us how many series you have, which gives us a good approximation of your hardware requirements or the sort of load your system might be under. And this is sort of a great example of something where you could use a similar curl command and it would be awful. But using the InfluxDB CLI makes it less awful. On that note, take a sort of short break, and if you have any questions about the InfluxDB CLI, like a 2-minute break, please ask them in the Q&A right now. And then we're sort of going to move on from the CLI to talking about configuring the InfluxDB process. All right, so there may be some questions that we didn't get time to answer right now, but we'll get to those towards the end of the presentation. So on that note, we're going to hop into configuring the InfluxDB process. So there's a large TOML file that comes along with any InfluxDB thing, and sort of we're going to go over the various sections, and I'll talk about which sections, what it does, and how you should use it. So the first section here is this meta section, and you really don't need to touch this area too much unless you're planning on running a cluster, in which case you may want things to bind to sort of different addresses and whatnot. But the meta section sort of defines what the meta service does, and the meta service is a service that where InfluxDB instances participate in Raft. Raft is the consensus protocol that InfluxDB uses for distributed computation. So the major sort of sections here, we have enabled. So this says that this node has this meta service enabled. The next thing that you have here is the directory where the meta service, the metadata is sort of stored. The typical thing on a Linux box is for it to be stored in varlib influxdb /meta. I would recommend, if you want to have sort of separate volumes mapped to various areas, you don't need to do that for meta. Meta has a very, very low write volume, so I wouldn't worry about this too much. If you want the Raft consensus to take place over HTTPS, you can specify that stuff here, where the HTTPS enabled should be true, and you specify the certificate that you want to use. The next sort of top level section that sort of has some implications is the data section. So the data section controls where the actual shard data for InfluxDB lives and how it is flushed from the wall to sort of disk. We'll talk about what wall is in just a second. dir is the directory, and there's a bunch of other sort of configuration options in here. And I would suggest that most of the defaults in here should work for most systems. So unless you're experiencing some sort of performance implications, and you've tried a bunch of various other things like mounting disks in separate locations, don't touch these. And sort of on that note, one thing I may recommend, or I would recommend that you do if you have very high performance or if you're operating on spinning disks, is you should split the dir and wall dir directories. So the wall is the write ahead log. It's a sort of a data structure that InfluxDB uses to achieve high performance before flushing things to disk. So if you are looking to have a very, very, very high performance system, I would recommend putting the wall dir on a very high performance directory, a volume that maybe has about 1,000 IOPS or something like that, and maybe putting your dir directory on something that has a volume that has maybe about 500 IOPS. And most likely you'll probably want to disable the various logging things here, just because InfluxDB loves to pollute logs as much as possible. We'll love producing logs. It's probably our favorite thing. So sort of, again, the takeaway from this section is if you need very, very, very high performance, split your dir and wall dir onto separate volumes where wall dir has more IOPS. The next section here is the hinted handoff, which is a queuing system that InfluxDB uses if there's ever any problems in a cluster. And the important thing about this is you only need this enabled if you are using a cluster. If you're not using a cluster, this section is entirely useless. It doesn't do anything. A single node should never be putting anything into a handoff. So if this is the case, you're going to want to, if you're only running a single node, you're going to have this enabled be false. And one thing I think is important is the structure of the points that go into the hinted handoff queue. If there's a network partition in your cluster, is bare line protocol. So you may want something that has a lot of disk space. That maybe is a very slow, a small number of IOPS, so maybe spinning disks with a lot of data, because it can fill up very, very quickly if you're not certain that it'll be emptying soon. So if the partition goes on for a very, very long time, it's not unforeseeable that there would be gigs of data in a matter of hours or a matter of minutes before the partition is removed. So if you are running a cluster, maybe have a large spinning disk where the hinted handoff directory is mounted. The next sort of up-level section that I'm going to recommend that you sort of have on is this monitor section. So we have store enabled true, store database underscore internal, and store interval 10 seconds. So the monitor service writes diagnostic data about the database to it. And the main reason why I think you should always have this sort of enabled is if you don't, it makes it particularly difficult for someone on the support team, for us to diagnose what is wrong with your database. The more information we have, the better we can do. The more information you have, the sort of more aware you can be about your system. So I would always recommend having this enabled. I can't imagine why you would want a database called underscore internal, but if you want to change it to something else because you want to use that database name for yourself, you can. But sort of the takeaway from this is I really think you should have monitor enabled because it helps us diagnose the system. There are cases where you may want to increase the store interval to maybe a minute or 2 minutes or even 10 minutes, but it's definitely important to try to have that data. And if maybe you're saying that this is causing too much stress on your system, which it shouldn't, then maybe bump up that store interval because it is very important to have that data around. The next section that I think is important is the HTTP section. So this runs or configures the HTTP service. So the HTTP service is the thing that you interact with when making sort of basically any requests of the database. So if you don't have this enabled, you will not be able to make an HTTP request to the database. You will not be able to query it. So you should always have this enabled. You may want to put it onto a different port, which is perfectly fine. And you may want to have sort of auth enabled, and or you may want to have it under HTTPS, which you can do by specifying the various flags. So HTTPS enable true and HTTPS certificate, give it your certificate, not the one that's listed there. The sort of final things I'd like to briefly talk about are these service configurations or services that we allow. So you can write to InfluxDB in various sort of formats. And the formats and protocols that we accept are graphite. So if you give us graphite data, we can write graphite data into the database. If you go look in the section, there's a bunch of sort of specifics around the exact sort of configuration options. You can write over UDP or TCP with the graphite plugin, so the two things that graphite allows. And you can sort of use templates to manipulate the structure of the data that is coming through. We allow for data to be written in OpenTSDB format. And I believe the only restriction there is that you can only use millisecond level precision last time I checked. And I believe it allows for, I don't remember if CollectDB allows for UDP, OpenTSDB allows for UDP and TCP. I think it might only be TCP. Not entirely sure though. The next thing is the collectD format. So if you're using collectD to receive or sort of get all of your data, you can send it over to collectD over the collectD format. I believe collectD also allows you to output in graphite format. And because of that, I might recommend, if that is true, which I think it is, I would recommend that instead of using the collectD endpoint, I would use the graphite endpoint. The graphite endpoint is a little bit more configurable than the collectD endpoint. So it allows you to sort of model the shape of your data in InfluxDB a little bit better than the collectD plugin. And sort of finally, InfluxDB accepts writing line protocol via UDP. So if HTTP is way too cumbersome, there's way too much going on there for you, and you really just want to get data into InfluxDB as fast as possible, you're going to want to use the UDP endpoint. The biggest problem with this is you must be it must be okay that you lose some data because UDP is a connectionless protocol and some data will be dropped. So if you do decide that you need really, really high performance, and by really, really high performance, I mean 500,000 plus writes per second, then you may want to consider UDP, and you might want to be able to experience a little bit of data loss. The sort of final note that I have about sort of configuration is something that's actually not documented. We need to add to our documentation, which is you can use environment variables on an instance to overwrite any of the configuration options in InfluxDB. And sort of the environment variables will always take precedence to configuration options. So there's a specific format that the configuration options must be written in, and that is InfluxDB underscore the name of the section in the configuration file underscore the parameter name equals the value of the thing that it stores. So an example of this is you could say InfluxDB underscore HTTP underscore enabled equals false. And what this is saying is that we want the HTTP service, the option and the enabled option in the HTTP service to be false. And then similarly below we have InfluxDB underscore hinted-handoff hinted underscore handoff underscore dir. And what this is saying is the dir option in the hinted-handoff section of the configuration file should be tilde.influxdb/hh. So we're setting it to be the dot file in our root directory or in our home directory. And sort of this is something that I think is important and very useful. So if you ever need to set a particular environment variable, you don't have to go and manipulate the config explicitly. You can just set environment variables on the machine. And on that note, I think we're sort of getting to questions. So thank you guys for your time. I hope this has been insightful, and we're going to hop into the Q&A right now. So if you have any questions, feel free to sort of ask them in the Q&A.